Hi everyone, in this video I'm going to continue to work some more integrated rate law problems for AP Chemistry. So the problem we're going to be solving is number 9. So experimental data for this reaction has been plotted 3 different ways. What's the order of the reaction with respect to A, and what's the initial concentration of A? So what you're looking for is the graph that's linear, which is clearly this one. When 1 over concentration first time is linear, it's a second order reaction. Done. It doesn't ask you to, but if it said what's the rate law, it would be rate equals Ka squared. And the second part of the question, what's the initial concentration of A? So I want to know what's the concentration at time 0. And a lot of mistakes are made. First, people come look at this first point and say that's the initial concentration. Well, no, it's not at 0 seconds. And 2, this data right here is 1 divided by concentration. So that's not even concentration. Concentration means this. So I could come again to this graph. But again, that is not time 0. That's 1 second. So we have to solve for initial concentration. Because we don't have reaction rates, how we solve for initial concentration is through our integrated rate law, which for a second order reaction is this. Now a few things before I can start plugging into this. We need to find K. K is your rate constant, and it is the slope of this graph. Slope equals K. How do we find slope? Good old rise over run, like back in 7th grade. So my rise, and I'm just going to pick the first 2 points. It doesn't really matter. So it goes 30 minus 20 over my run. That's 2 from 1. So 30 minus 20 is 10 over 1. My slope, which is my K, is 10. And because it's a second order reaction, the unit for K is m-1 seconds to the -1. So I know my K now, and I'm trying to find AO. So I need to pick a point for AT. You can pick any point. It doesn't matter. But what you need to be careful of is if I pick 20 right here, that is perfect. But this 20 is 1 over concentration. So when I plug it into my integrated rate law, I don't do 1 over 20 because this is that variable right there. It's already been 1 overed. So I don't reciprocal it again. I just plug in 20 minus 1 over AO equals K, which is 10. And what's the time right there? The time is 1, so 1. Now it is, and I'm going to finish that right here, 1 over AO, and that's a -1, equals, this 20 is right there. I would subtract 20 from both sides. 10 minus 20 equals -10. A negative on the left, a negative on the right. They cancel out. 1 over AO equals 10. You can multiply AO on both sides. Those cancel out. We have 1 equals 10 times AO. Divide both sides by 10. The initial concentration of AO is, I ran out of space, 1/10, also known as 0.1. And because it's concentration, the unit is molarity. That's how you would solve this. Relatively simple. The biggest mistake is if you're pulling off of this point, don't put it at the bottom. That is all of this. So it's just that number. Don't do anything to it. I'm going to work another problem on this video. The one I want to work is a first order, and it is this number 19. So this reaction is first order. A solution originally at 0.6 m, so that is my AO. Technically H2O, doesn't matter. It's found to be that after 54 minutes. So there's my AT, there's my time. Find the half-life of this reaction. Whenever you should see half-life, you should double check your formula chart. The formula for half-life is T1/2 equals 0.693 over K. So if I want to find half-life, I need to know my rate constant, which is K. None of these variables are rate constant, but I can find them through my integrated rate law. Because it's first order, I know it's this integrated rate law. And I have everything. AT is 0.075. Now I have to natural log it because this is not it natural logged. It's saying that's the concentration. Minus natural log of AO, 0.6 equals negative K times the time, 54. And again, just be really careful with signs on this problem that you don't mess a sign up. When I do those, I get negative 2.079 equals negative 54K. Divide both sides by negative 54. And we get K equals 0.0385. And because it's first order and time is minutes, the unit is minute to the negative 1. Now that I know my K, I can find my half-life. Half-life equals 0.693 divided by K, so divided by 0.0385. That half-life is 18 minutes. Boom. So integrated rate loss can be scary for AP Chem students because it's the first time you've seen these formulas, but really it's just getting the hang of it and plugging and chugging. Probably the hardest part is you make it harder than it needs to be. Pay attention to the order, pick the right formula, and plug and go. I hope this video helped.